Resin 3D printing has always come with a few hard truths. Messy cleanup, toxic fumes, and fragile decorative prints that look great on a shelf or tabletop battle, but can't handle real-world use. But what if there was a resin printer that broke those rules? One that's cleaner, safer, and capable of producing parts as strong as injection molded plastic with precision that puts even high-end FDM printers to shame. Hey guys, I'm CJ and this is the Formlabs Form 4, a professional grade resin printer built for engineers, product developers, manufacturers, and businesses, and maybe even hobbyists looking to turn their passion into profit. It promises cleaner workflows, safer materials, and industrial grade precision, but with a higher cost of entry than a typical consumer printer and some software quirks. Is it a game changer or just an expensive resin burner? In this review, we're going beyond the spec sheet to see how the Form 4 actually performs. We'll break down its unique print process from speed and accuracy to mess-free and streamlined post-processing workflows. We'll also dig into its build quality, serviceability, and upgrade potential to see if it's built to last. Of course, software is just as important as hardware, so I'll test preform and dashboard in a professional workflow, and most importantly, I put 4 different Formlabs materials to the test to see if the print quality, durability, and precision live up to the hype. And in the end, we'll answer the big question: who is this printer really for? If you're a business or serious maker, is this the tool to take your work to the next level, or should you look elsewhere? I spent a long time with this printer, ran dozens of jobs using multiple materials. This is going to be a long one, but will definitely be worth the deep dive. Let's do this.
It's the money.
Now, normally I'd kick things off with the unboxing and setup, but because the Form 4 package was so extensive, I already did a full unboxing and setup video. If you haven't seen it yet, you can check it out here. But to summarize, I was able to go from unboxing this printer to starting my first custom print job in under 15 minutes. That's honestly impressive. For the most advanced resin printer I've ever reviewed, it's also one of the easiest to set up and start printing. So today, instead of spending time on the setup process, we're jumping straight into the specs and features of this machine. The Formlabs Form 4 is a mass stereolithography or MSLA printer designed for serious production work. It's a desktop unit measuring 398 by 367 by 554 millimeters and weighing 18.3 kilograms or about 40 pounds. However, the up and over lid requires 813 millimeters or about 32 inches of vertical clearance to fully open. That's something to consider if you're planning to put it under a shelf or cabinet. At least the lid is smooth and soft closing thanks to a hydraulic piston assist. For the build volume, the printer offers 200 by 125 by 210 millimeters. Formlabs provides 2 different build plate options. The standard aluminum build plate is precision machined, perfectly flat surface with integrated drip guards to help keep things clean. Then there's the build platform Flex, a flexible stainless steel plate that lets you pop prints off by easily squeezing the handles to flex the plate. No scraping, no mess. Moving down, there's a built-in camera with an integrated light that allows for print monitoring and time-lapse recording. There's a fully automated resin handling system. The printer has a dedicated resin well that holds Formlabs' proprietary resin cartridge, and it manages everything for you, detecting the resin type with an RFID scanner, tracking resin levels using a load cell, and dispensing only the exact amount needed. The resin vat is a molded plastic tank with a dual layer release film that is heat welded into place, ensuring zero risk of leaks. It has an expected lifespan of 75,000 print layers, which is significantly longer lasting than typical NFAP sheets used in hobbyist printers. The vat also has an RFID chip that the printer tags with the resin type on first use. And if you ever want to reuse the same vat for a different resin, you can reprogram the RFID directly from the printer's menu. Each vat also comes with a reusable lid, making it easy to store resins separately and swap them out as needed. A unique feature of the Form 4 is its resin mixer, and it's more than just a stirring tool. It actively mixes the resin between each layer, which is essential for specialized filled resins like the glass-filled Rigid 10K that need consistent distribution. The mixer also helps with uniform heating since the two heating elements are located on the left and right sides of the vat. It even reduces resin drag, which helps with the thin and delicate parts that would normally struggle in deep vats of thick resin. On top of that, it includes a debris sensor, so if a print fails and leaves a chunk of cured resin in the vat, the printer pauses the job automatically to prevent further failures. Now, let's talk about the real heart of the Form 4, what Formlabs calls the low force display, or LFD. On paper, the raw specs might not seem all that exciting. The display has an active area of 202 by 127 millimeters, a 50 micron pixel size, giving us about a 4000 by 2500 pixel resolution. Compared to cheaper consumer printers boasting 16K screens and sub 20 micron pixels, that doesn't sound groundbreaking, but resolution alone doesn't tell the whole story. Instead of just relying on high pixel density, Formlabs developed a backlight unit that fundamentally changes how the light source works. It consists of 60 uniform 405 nanometer ultraviolet LEDs, which are collimated through a convex lens array and a honeycomb baffle that results in a parallel light source, meaning UV exposure is evenly distributed across the entire display, minimizing light bleed and distortion. The peak intensity of this UV array is 16 milliwatts per square centimeter, making it one of the most powerful UV curing systems in a desktop MSLA printer. This is where the Form 4 really differentiates itself from consumer MSLA printers. Most standard resin printers rely entirely on their fixed LCD pixel grid to define detail, which often results in pixelated edges and jagged surfaces unless software-based and detail blurring, anti-aliasing is applied. But Formlabs takes a slightly different approach by using firmware-driven grayscale pixel and sub-pixel exposure control, allowing partial exposure of individual pixels. Instead of being limited to an on or off pixel structure, this system enables smoother gradients, sharper edges, and details that exceed the native 50 micron pixel size. On top of that, Formlabs added a traditional LCD backlight in addition to the UV array, which improves print quality as it enhances contrast, ensuring clear definition between printed and non-printed areas, prevents UV light bleed, reducing unintentional curing and improving feature sharpness, and maintains uniform brightness across the entire LPU, preventing inconsistencies. You might also notice that the LPU surface has a textured finish, and that's intentional. This texture doesn't negatively impact print quality, but it does serve a crucial function. It allows air to pass between the screen and the release film, helping to break the suction and make the peel process much gentler. The build plate lifts in two stages, a slow peel motion first to prevent layer peels distortion, followed by a faster lift to allow the mixer to move before the next layer starts printing. This system is why the Form 4 can achieve print speeds of up to 100 millimeters per hour with fast resins, or between 20 and 50 millimeters per hour, depending on the material and layer height. To round things out, the Form 4 has a 7-inch 1280 by 800 pixel interactive touchscreen with a simple, intuitive interface, USB-C connection, an Ethernet port, and internal Wi-Fi. It's also packed with onboard sensors, including a Z-axis force sensor in the resin mixer, build plate and vat sensors, a temperature probe for the vat, and an accelerometer to ensure the printer is level. At the end of the day, most of the real engineering and technology in the Form 4 is packed into the low force display. It might not have the highest resolution display on the market, but it's easily the most advanced. Whether it's precise light control, grayscale pixel exposure, and 16 milliwatt per square centimeter UV array actually give it an edge in print accuracy and consistency, well, we'll find out soon. But before we dive into the dozens of print jobs I've run on this machine, let's talk about something that adds a ton of value to this printer: the exceptional build quality, ease of user serviceability, and potential for future upgrades. First off, build quality and materials are exactly what you expect from a $3,500 piece of equipment. The Form 4 is constructed from a mix of steel, aluminum, polycarbonate, and injection molded plastic, and everything is used where it makes sense. The machined steel front panel adds rigidity, while the color-matched aluminum side panels balance durability with weight reduction. The injection molded plastic parts like the rear panel and display mounting platform are perfectly integrated for functionality rather than just aesthetics. Now, if there's one area that feels a little less robust, it's the Z-axis. The Form 4 uses an 8mm lead screw paired with a single 15mm linear rail, which feels a bit on the lighter side, especially compared to something like the massive C5 grade Z-axis of the Reflex RS. That said, there's absolutely no noticeable wiggle or vibrations in the movement. In fact, this is the fastest Z-axis I've ever seen on an SLA printer. One of my favorite features is that most of the tools you need for basic maintenance are included right here, neatly organized in the Formlabs printed tool category. Every fastener is fully accessible. One Allen wrench is all it takes to remove every exterior panel, giving you direct access to all the user serviceable parts. And that's the thing, this printer is actually designed to be serviced. Formlabs sells replacement parts directly on their store, meaning that after your initial or extended warranty period, if something like the cooling fan, RFID sensor, or even the power supply dies, you don't have to send the whole printer in for a very expensive repair. You can just order the part, watch a YouTube video, and replace it yourself. Consumable parts are also easily replaceable. Need a new display? You can order one, remove 8 screws, unplug an HDMI and power cable, and swap it out in about 10 minutes. Even the light processing unit can be removed with just a handful of screws without tearing down the entire machine. What's even more encouraging is that Formlabs still supports their products all the way back to the Form 2, offering replacement parts even for this 10-year-old model. However, Formlabs has decided to wind down full support for the Form 2 by the end of 2025. So what do you think? Is over a decade of support long enough given how quickly 3D printing technology is advancing? Let me know in the comments below. Because while Formlabs hasn't announced any plans for it, this modular design makes future upgrades a real possibility. If Formlabs improves the display in the future, there's a good chance you could swap in a higher resolution display instead of replacing the whole machine. Even the main board uses a Raspberry Pi compute module, which in theory means a CPU upgrade could be very possible down the line. Regardless of whether upgradability actually happens or not, the robust build quality, smart engineering, ease of serviceability, and access to replacement parts, which means this printer, which is intended to see heavy daily use, is built to last. With proper maintenance, the Form 4 isn't just a short-term investment, it's a machine that can keep running for over a decade at least. Now, I already covered the preform software in my initial video, and honestly, I don't have much more to add except to reiterate what I've already mentioned. Support touch point size and in some cases support density were problematic with every material I tested. I ended up cutting the touch point size in half and reducing density to 85% across all resins, which mostly worked, but I still ran into some post-processing failures due to support issues. For example, on a couple of mouse bodies, the support densities was too thick and removing the supports damaged the parts. Overall, I found preform support generation algorithm to be problematic. Not only are the automatic support settings poorly tuned, but manual support adjustments are extremely limited. There's no way to apply different types of supports to different parts of the model, like heavy, medium, or light supports, which is something you get in slicers like Chitubox, and it would have been a huge help here. That being said, all other print settings were dialed in perfectly for the materials I used, and as long as I manually adjusted the supports, my prints came out flawlessly. And if I needed to tweak anything further, Preform exposes all slicer settings, so I can, for example, start adjusting the support touch exposure by reducing the UV dose instead of just shrinking the size. Preform actually has more fine-tuning control than any other slicer I've used, and it uses the correct units of measurement. Instead of just exposure time, it gives you actual UV exposure dose settings, which is so much better, especially when UV intensity is often controlled separately, usually on the printer itself. Now, this level of material control could technically allow you to calibrate and use third-party resins on the Form 4 without buying the $2,500 open materials license. But if you do and something goes wrong, like overfilling the vat and splashing resin all over the internals, Formlabs may refuse to cover repairs under warranty. Now, if your warranty is already expired though, and you want to save money by refilling a Formlabs cartridge with a $20 Amazon resin, I guess it's an option. But here's the problem. The existence of open material mode creates an artificial barrier between users and the materials they want to use. It's not about technical limitations because the slicer already gives you full access to material settings. It's about whether Formlabs will support your machine if you do step outside their ecosystem. And this is exactly the kind of closed ecosystem approach that frustrates the 3D printing community. We've seen it before. HeyGear's Reflex printer got shredded for locking users into a proprietary system, and Formlabs is running a very similar model here. The issue isn't just the cost of the printer and the resins, it's the idea that users are forced to pay extra just to have material freedom on a machine they already own. A more reasonable approach, if Formlabs insists on locking open material mode behind a paywall, it should at least be released after the printer's initial warranty expires. At that point, they're no longer responsible for material-related failures, and owners who have already invested in the machine should be free to experiment with other resins without an additional financial penalty. The 3D printing industry has always thrived on innovation and openness, and while Formlabs' material ecosystem is undeniably powerful, locking users into it with financial barriers only alienates potential buyers. I already expect this to be the most debated point in the comments, so let me know what you think. Now, this is where we find out if all this advanced technology, engineering, and materials actually translates into advanced print, and the short answer is yes. Yes, they do. For testing, Formlabs sent over Gray version 5 and Clear V5 resins, but since I've heard from Formlabs users that the real strength of the Form 4 lies in its advanced material selection, I went ahead and bought a bottle of Durable and Tough 2000 resins, along with a dedicated resin vat and mixer for each one. And honestly, if you're spending $3,500 on a printer, an extra $125 per vat and mixer probably isn't a huge deal. For me, the time and effort saved plus the completely mess-free workflow makes it absolutely worth it. Switching resin tanks takes less than 2 minutes. Just wipe down the build plate, swap out the vat and resin cartridge, and you're good to go. That made it easy to use multiple materials for a single project. That said, buying 2 additional bottles of resin and the accessories sent me back over $600, which is more than an entire Saturn IV Ultra 16K printer cost. So these better be the best photopolymer resins I've ever worked with. Spoiler alert, well, they are. Check this out. I designed and printed a custom ball peen hammer using the Durable resin, and it's actually durable. I've used it to form and texture copper plate, and it held up perfectly. Here's a super tough phone case. All of my test prints were either prototypes or functional devices. For example, I printed this desk lampshade in Clear V5 using only bottom supports, and it turned out great. The entire structure is made up of thin fiber optic-like filaments, and I fully expected them to be a wavy mess or fail multiple times without supports holding them in place. But thanks to Form 4's precise resin dispensing system, which releases only the minimum amount of resin needed, and the mixer evenly spreading an ultra thin layer across the vat, there was zero noticeable resin drag problems. That's something that would absolutely be a problem on a printer with a deep resin vat where thin structure gets moved around by thick viscous resin between layers. Now, I did have a couple of failures with the Clear V5, but Both were user error. This microfluidic gradient chamber printed perfectly with great internal detail in the capillary channels, but I didn't post-process it properly. Some resin remained inside the channels when I cured it, well, ruining the internal structure. I also attempted to print this human heart model without any supports inside the heart chamber, but I ignored Preform's warning about some unsupported minima, and the print partially failed right at the very end. Beyond print failures, I had a couple of post-processing issues I've already talked about, specifically breaking parts while removing supports. I snapped off both buttons from this mouse body printed in Gray V5, and I also chipped a small piece of the bottom of this ultralight mouse body printed in Tough 2000. And looking at Preform's auto-generated supports, I'd say that's just way too many supports for such a small area. Especially with Tough 2000, I had to manually support or at least remove excess supports for the rest of my prints. But back to the ultralight gaming mouse. I printed it in 3 out of the 4 materials, and all of them came out with perfect fidelity. Dimensional accuracy was spot on. No layer distortions, no peel force warping, no shrinkage issues. X, Y, and Z compensations are all pre-calibrated for each resin, so everything fit together perfectly. That accuracy across materials also meant I could mix and match components. For example, Clear V5 was fine for the mouse body top, but it was too brittle for the bottom. The thin screw post cracked when I tried to tap the threads. Tough 2000, on the other hand, had no issues, and I was able to directly thread the post with the 1.5mm screws. And despite chipping a corner when removing supports, once Tough 2000 was fully cured, it was virtually indestructible. Hands down the closest thing to real ABS I've ever used in a resin. I also printed the mouse body in the durable, which worked surprisingly well, except for the buttons were a little too soft and floppy to be functional. But if you're looking for a mouse that can survive a rage quit impact with the wall, this is it. Now, the project I spent the most time on was this Stargate model. It's a fully functional build where the inner gate ring spins when you turn the DHD, thanks to tiny gears, worm screws, and a 1mm universal joint. This has been impossible to print on consumer grade printers because of the insane level of precision required. I originally printed the entire model in Gray V5 resin, and while every component was dimensionally perfect, the gray resin was a bit too brittle for certain parts, especially the outer ring structure, which has incredibly thin and fragile sections, and the gear mechanisms, which take too much stress. So I reprinted key parts in different materials. The rings, U-joints, and rods went into Tough 2000 for extra durability, while the actual gears were printed in the durable resin to take advantage of its low friction, self-lubricating properties. I also printed the Event Horizon planes and connection struts in Clear V5 resin. That's 3 different resins, and every single piece, even down to the tiniest components, printed with micron level precision and fit together perfectly. And one of the huge advantages of Formlabs materials is that they certify that the physical properties of their resins will always be exactly the same, from this bottle I just bought to a bottle of durable I buy 2 years from now. Now, I was hoping to have this entire model fully assembled for this video, but I'm still waiting on the resistors I need for the micro LED lighting, and I'm also gonna reprint the spinning center ring in clear so I can light up the symbols. But when it's finished, I'll post a full build video over on my admittedly seldom used CJ Build Stuff channel. Now, I've demonstrated how the Form 4 can be used to create original functional projects, produce scientific and educational models, and prototype designs. But what about hobbyists? If you're someone who prints a new campaign miniature set every few months for your tabletop crew, then this printer isn't for you. But what about the hobbyist looking to turn their hobby into a business? Well, first off, yes, the Form 4 can print highly detailed miniatures. A couple of weeks ago, I made a community post comparing 2 minis side by side, one printed on the Form 4 and the other on the Saturn 4 Ultra 16K. At a 3-inch viewing distance, you could see a minor difference in quality. The sub 20 micron pixels of the Saturn 4 Ultra 16K, after proper resin calibration, produced a sharper, more detailed model. However, once I applied a very thin layer of primer, the prints became indistinguishable. So while the Form 4 isn't chasing extreme pixel density, it still delivers excellent print quality for miniatures, but its real advantage comes down to materials and production scalability. Instead of printing multiple resin minis, I could print a single mold in rigid 10K, a glass-filled heat-resistant resin, and then with a desktop injection molding machine, mass produce hundreds of ABS injection molded miniatures for a fraction of the cost. Professional users are already using machines like the Form 4 for low volume injection and blow molding, and this concept can apply to many of the projects I've shown here. Take the ultralight mouse design. Once I perfect it, instead of printing every component in TUF 2000, I could design and print a mold and then injection mold the components, reducing my per unit cost significantly. Now, I could go on about the accuracy, quality, and superior mechanical properties of the prints, and I do have a few more models on the table, but the key takeaway is this. This isn't a hobbyist machine. This is a business tool built for people who need to produce highly accurate and functional components quickly and efficiently. Beyond print quality, there are a couple of other key factors that to me make the Form 4 a great business tool, and the first is its simple mess-free workflow. In my unboxing video, I showed just how streamlined the process is. Pop the finished model off the flex build plate, drop it directly into the pre-wash bucket, then transfer it straight into the form wash. Once the cycle is done, the form wash automatically lifts the part out of the APA, so I can just move it right into the form cure for final curing. That entire workflow in over 24 print jobs, not a single drop of sticky resin anywhere outside of the vat. A big part of that is the Build Platform Flex, which I believe is an extra $100 and is worth every penny. The second major advantage Formlabs has is resin safety. Unlike most consumer grade resins, Formlabs formulates and manufactures all the resins in the US, and more importantly, they don't contain acutely toxic compounds like acryloylmorpholine or ACMO, which is found in a lot of standard 3D printing resins. Because of this, the Formlabs resins have a minimal odor. In fact, most of the resins I tested smelled very faintly like household paint, as opposed to the usual sharp chemical resin smell. But even more importantly, I ran the Form 4 in a small sealed room in my basement, and my VOC and formaldehyde monitor never registered any air quality issues. It stayed in the green the entire time. Of course, adequate ventilation is always the best option, and the Form 4 includes a dedicated rear exhaust port that can be connected to either a centralized or individual ventilation system. But I'll say this is the first resin printer I've ever operated for an extended period in my home without anyone complaining about the smell. At the end of the day, the Formlabs Form 4 isn't just another resin printer, it's a professional tool designed for businesses, engineers, and product developers who need precision, reliability, repeatability, and access to highly specialized material ecosystem. It's not a hobbyist machine, and that's reflected both in its workflow and pricing. And when it comes to choosing a professional desktop resin printer, the Form 4 isn't the only option. Machines like the Zortrax Inspire 2 and Raise 3D DF2 offer similar performance and automation features, making them strong competitors. But what sets the Form 4 apart is its deeply integrated and certified material ecosystem, which provides fine-tuned resin performance and a streamlined workflow that's hard to match. And now with Formlabs dropping the price by nearly $1,000, it's suddenly the most affordable professional desktop resin printer in its class. However, for individual hobbyists considering entrepreneurship, that $3,500 price tag could still be a major barrier to entry, and that's why this review isn't the end of the story. This turned out to be the longest review I've ever produced, but I'm not done yet. In an upcoming video, I'll be directly comparing the Form 4 to a prosumer printer, the Haygears Reflex RS, and a consumer hobbyist printer, the Elegoo Saturn 4 Ultra 16K. I'll be using Haygears resins and some high quality consumer resins, including Formlabs Creator Series, to see if we can get accurate functional components like this gaming mouse from a more affordable machine. So if you want to see that, make sure you're subscribed so you don't miss it. Thanks for watching, and I'll see you in the next one.